Hi, I'm Dan from Sukup Manufacturing, and today we're going to go through the Sukup Automation Air System settings. Let's hop right into the software. We're going to select Air System 1, and then we're going to go to Settings. Now on this first settings screen, there are 5 timers here: blower on delay, blower off delay, airlock on delay, airlock off delay, and auto adjust delay time. Blower on delay is the time after the command is told to tell the air system to start. How long is it going to wait before the blower starts? This is typically 0, and the default setting is good here. Blower off delay is how long the blower will continue to run after the go signal is removed. With blower off delay, I recommend at least 30 seconds. It depends how far the bins are from the dryer and how much pipe you have. You may need to make that longer, and you could maybe make it shorter. It just depends on the site layout. 30 seconds is the default to start, and that's usually good for most sites. Airlock on delay, once again, as an on delay, it's the time before the airlock starts after it's ready to just provide some delay there. Airlock off delay is the time the airlock runs after the airlock shuts off. This one I might change depending on your site setup, assuming that it's safe for everyone. When the dryer, for example, shuts off, it's going to continue to run the airlock for however many seconds you enter in here, so that the airlock will clean out and there'll be no grain left in there. So I would recommend something along the lines of 5 seconds. However, I do want to caution you, if you're going to set the airlock off delay time, that you need to make sure that nobody can get their hands in it. So for example, if they flip the rear door up on or the rear discharge chute up on the dryer, that nobody would be able to reach their hand down in the airlock and lose a hand, because the unload auger is going to stop on the dryer, but the airlock will continue to run for 5 seconds regardless of which fault it is on the dryer. So if the site permits and it's safe, you can set that to 5 seconds to help clean out your airlock. Auto adjust delay time. What this is when the air system starts up, how long do you want to run at the max capacity of the air system, which means the VFDs are at full speed and the dynamic bleed valve is fully closed. And what this does is allow the grain to get in the pipe from whatever you're feeding the air system with, allows it to find out how much it is before it starts turning down. If it started turning down right away, then you could end up plugging the air system because the system started turning down before it actually had the grain in it, because it takes a little while for the grain to come down through the metering rolls and into the air system. So 60 seconds is the default time. If you want that to be less, you can, or if you want it to be more, you can. But that's just where, after the air system has been ready for grain for 60 seconds, then it's going to start slowing down or making changes after that point. Let's hop into the advanced settings. Well, actually, before we do that, auto unplug is disabled. On the left here, if you want to enable auto unplug, just touch the button. It'll become a green check. What that does for you is if the air system starts to plug, it will stop itself. It'll tell whatever, if it's connected to a Sukup QuadraTouch Pro, it'll tell the drying unload to stop running. It'll attempt to unplug itself. And if it succeeds, then when it's done unplugging itself and gets back up and running and ready to go, it's going to tell the dryer, okay, go ahead and send me more grain, and the dryer will resume unloading without ever shutting down the dryer or requiring user interaction. If you don't have a Sukup QuadraTouch Pro, it'll still do the same thing. The only difference is you're likely going to lift the door on your rear discharge chute of your dryer, because it's going to stop the airlock, which is probably going to shut the dryer down. But at least when you come back, the air system should be cleaned out. Let's hop into the advanced settings. In the advanced settings on the left-hand side here, auto control settings, there are 3 settings types. Pressure loop settings, I'm going to click into here. I will talk through these. However, I highly recommend, if you do not know what you're doing, you do not touch these settings. This is the loop control. So this is when you're in pressure VFD control or pressure DBV control PID, which stands for proportional integer derivative. These are the numbers that are used in that loop to determine how fast to speed up or slow down. We'll start on the top right here. On the top right here, loop gain. Loop gain is the proportional number. It has to do with how aggressive it's going to be based on how far it is from the set point. Loop reset rate is the integral part. That's, if you look at it from a time standpoint, that's the past. How long have I been away from the set point that I'm set to, and that number will become more in the mathematical equation to determine how to speed up and slow down accordingly based on how long you've been away from the set point. Loop derivative rate, third one down. What that's for is that's future. So if you look at it as present, past, and future for PID, what you're going to find is that the present is what it's doing right now, the past is where it's been and how long it's been, and the derivative, or the loop derivative rate here, is going to give you the ability to guess where it's going to go based on the rate of change. So if it's going 2, 3, 4, 5, 6, based on how fast it's moving and how long, it thinks I'm going to overshoot, and it'll help keep you from overshooting by turning it down. Even though you might still be below your set point you're shooting for, you might see it turn down in order to prevent you from overshooting if it sees the rate of change too quickly. Lag rate has to do with how long it takes after you make a change before you actually see a change start to happen. Loop cycle time is used for the calculation. Don't touch that, 1,000 milliseconds. If you mess with that, it will mess with the calculations in the PLC. Leave that where it is. On the top left over here, we have rate of change, ROC, and it's enabled currently in this, and the rate of change limit is 1.0. Down below, what that has to do is when it's making a calculation, how far can it jump, how quickly, how fast. It's a limitation on the PID's calculation to prevent something from slamming wide open or slamming shut too quickly. It makes it happen over time. The deadband above and below, which are the last two settings on this page, they have to do with when you're close to your set point. If your set point is 3.0, if you're 3.2 to 2.8 in this instance with these 0.2, that's close enough, we don't need to make any changes. It's just meant so that it's not constantly hunting, trying to get the perfect 3.0. It's just made to get you close to what you're shooting for, because in an air system that doesn't matter. Let's jump back. Next setting, custom mode settings. Custom mode settings, there are two control modes on the touchscreen. There's VFD control mode and DBV control mode. And then each of those has two different types of a loop control. One of them is the custom loop, and the other one's the PID. We just talked through the PID loop. These are the custom mode loop settings. So starting on the top left here, stable time is 5 minutes. That's used for a future release, for a setting that we haven't released yet, but basically, if it was previously running stable at a set rate, it's gonna help us get there quicker in the future because we knew that where we were running for 5 minutes at least in the previous run time was gonna help us get started quicker. Like I said, right now that does nothing, but in a future release that will be a setting. Time to wait after change. So if I tell your air system to go from 33 hertz to 35 hertz, and then how long am I going to have to wait before I want to make another change? That has to do with how far the pipes are from the bin and how far the bins are in the air, etc. I mean, the total pipe length and the speed that the grain's moving through it might change how long it takes before you see the results of that. So if I make a change and I wait 12 seconds, do I know what the pressure in the pipe is now? Because it's fully made and fully aware. I would recommend leaving that at 12 seconds. Even if it's a little further, you're going to be close enough to where you're going that it shouldn't cause any crazy changes. But if you do want to change that, if it's a really close bin, you could probably lower it down. If it's a far bin away, you could maybe lengthen it out if you needed to. It just changes how aggressive it is because it's only making a change once every 12 seconds. On the right, the custom values, the pressure up multiplier and the pressure down multiplier. We want it to be more aggressive up than we do down. And what up is varies whether it's a VFD or a dynamic bleed valve. But the VFD, when you go to turn up the speed because the pressure is getting too high, you increase speed to lower the pressure. So the up multiplier in this case is going to be more aggressive in that direction because if the pressure gets too high, we're more likely to plug. So we want it to turn the VFD speed up faster than we want it to slow down. And what that does for us is helps keep us from plugging. And in the down direction, it's very slow, methodical, so that we can come right down in and run really close to where we want to based on pressure and current. One of the things I will point out differences between custom mode and PID mode is custom mode is our smart loop technology. It takes into consideration more than just pressure. It watches the motor current as well as the pressure in the system so that the motor current can be considered. So if we're slowing a motor down and the motor is getting near its full load amps, even though we may not have attained the pressure set in by the customer, it's going to stop turning down when it hits motor full load amps and not allow the customer to plug it by setting a set point wrong in the panel. It's going to say, I know you want me to go there, but no. All right, let's go back here. Let's go to auto unplug settings. So as we discussed earlier, the auto unplugs for unplugging when it senses pressure too high, these are the settings for that. During the auto unplug settings, there's 2 times that are really crucial in this. At first, once it starts back up, it's going to continue to open the dynamic bleed valve. It opens the dynamic bleed valve all the way open, and then it's going to continue to close it until it reaches motor full load amps. Once it reaches motor full load amps the first time, it's going to continue to run for the full current run time in the top here for 30 seconds. After that 30 seconds has gone by, then it's going to start to isolate. That's where the open amount and close amount happens. So if we're 27% open on our system when it's trying to unplug, it's going to go to that's your full load. It's going to keep turning until it gets there. When it hits 27 and it's at full load amps, it's going to wait for 30 seconds. And then once that 30 seconds has gone up, it's going to go down to 22 for a few seconds, and then it's going to go to 29 for a few seconds, and back and forth. It's just going to oscillate between 22 and 29 if 27 was the number that it came down to for full load amps. And the reason for that is it slugs the air through there to push it out. It goes 2 under where it was to try to allow the motor to get back up to speed so we don't trip and overload, and then it goes 5 below to try to push the grain out. It's going to continue to do that for the oscillation time of 30 seconds over here. Once it's done with that, it's going to stay running at full current amps for an additional full current runtime of 30 seconds at the end. On the right hand here, the only settings that we haven't talked about are these top 2, the unplug pressure. When pressure drops below 6 pounds, it considers itself unplugged. And so as long as the pressure drops below the 6 pounds when it's running its unplug cycle, then it will continue and restart the dryer. If it doesn't and it stays above that, it's going to say unplug failed and shut down your dryer. The unplugged start position of 100, it means drive the dynamic bleed valve open to 100 before you start. Typically speaking, I would set this parameter to 60. 60% open for the unload start position allows enough air to bypass that the motor doesn't overload. You can raise that if that doesn't work for you, if based on your dynamic bleed valve setting, but having it set at 60 is going to save you 40 seconds in your unplug process over 100. Because it changes by 1 per second. So having to shut from 100 to 60, I found, makes very little change, and it saves you 40 seconds in the unplug process. There's nothing wrong with leaving it at 100, it just makes it take longer. Next, we're going to talk about inputs, so pressure sensing setting. The air system is set up to be dynamic, so if the serviceman were to have a different pressure transducer with him that's not a 0 to 30, which is what it comes from the factory, if they had a 0 to 15, for example, or a 0 to 100 that was used in a pivot, for example, if they had it in their truck, they could wire it into this system. They would just have to put the range of the pressure transducer. So ours from the factory is 0 and 30 because it's a 30-pound pressure transducer. If they had a 100-pound pressure transducer, they'd put in 0 to 100. The other thing the air system allows you to do is to set the voltage range. Our voltage range from the factory is 0 to 10 volt DC. If they had one that was a 0 to 5 volt DC, all they would have to do is touch here and change that 10 to a 5 volts and it would work with their system. We wanted to keep it as dynamic as possible to better the customer and the end user. The other thing you can do, if it's a 4 to 20 milliamp, you can click and switch it over to current for the input if you don't have a 0 to 10 volt or a 0 to 5 volt or a 2 to 10 volt or any of those possible combinations, because it's almost infinitely variable from 0 to 10 volts. As long as there's something in that range, you can use it. We also have a 0 to 20 milliamp input, or in this case it's set to 4 to 20, but if it was a 0 to 20, you could change that 4 to a 0, or you could change that 20 to a 10 if you had a 4 to 10 milliamp signal, which is not very common. However, it gives you the variability if you wanted to use it. I am going to talk about current sensing settings next. So current sensing settings, here's something you're going to have to set. These vary depending on the type of drive for the blower. So in the current sensing settings page, here on the right-hand side, we just talked about the voltage milliamps selection. That's available here. You can change it 0 to 10, 0 to 5, 1 to 5, 1 to 10, whatever you see fit. Those are options, and the current sensing is available as well. You can flip this over to a milliamp signal or to a voltage signal. But on the left-hand side here, once again, the range is the range of the input. So for example, if you have a blue donut current transformer, because you're a line start system or a soft start, you can use that current sensing transducer, and most of those have a range of 0 to 200. They are selectable and they can be moved by moving jumpers, but from the factory, we would send it at the range 0 to 200. If you have a Mitsubishi frequency drive, the range is set because of the settings from 0 to 200. If you have a Schneider electric drive, an ATV 320 or an ATV 630, those are based on the drive's rated current times 2. And we have a chart available for you to tell you what the range would be, but it might be 0 to 133 on one drive and the next drive might be 0 to 211. It just depends on which drive you have. That number is going to change and you'll need to set it according to the input from the sensing. The last one is the motor full load amps, and the motor full load amps needs to be set. This is not motor service factor amps. Motor service factor amps is what you would put into a VFD or into a motor overload for the trip. What I want for motor full load amps is just the nameplate full load amps. So if the motor has a 72 amp input or a 76, depending on who the manufacturer is of the 30 horse motor, you would punch in 72 here, and that 72 with a service factor is 82.8. So your 82.8 is your motor overload, but just the full load amps here. This helps in the custom mode, because in the custom mode, we can look at the motor full load amps. I don't want to have your drive pushing it to its trip limit when I'm saying stop because you set the wrong set point. All right, let's talk about VFD control settings. So in VFD control settings, once again, we have the voltage, current, input, output options over here. So you can choose anything from 0 to 10, 4 to 20, 0 to 20 milliamps. However, you can click back and forth and choose which one's right for you. On the left-hand side, we have two different ways you can control the VFD. We have hertz or frequency, and we have percentage. So if you touch the frequency button, you can switch to the percentage. Minimum auto control speed and maximum auto control speed in percent, or minimum frequency, maximum frequency in hertz. In Europe and in some places, they use 50 hertz, for example. So you may want to change this to 50 hertz as your max control. And if you would, you'd change the middle one and the bottom one both to 50 hertz for your speed control. However, in the US, 0 to 60 is the standard, and in a lot of countries, 0 to 60 is also what they use. One thing here from a frequency standpoint on the controls, you're probably going to want to change your minimum control frequency at a bare minimum to 40, and you can go up or down from there. It has to do with how far you're blowing. If it's a really long ways, you may even have to go higher than that. If you're plugging and you're running in VFD control, I would recommend that you raise the minimum auto control frequency first before you do anything else, because if you allow the VFD to slow the grain down enough that it's no longer able to carry it vertically in the pipe up the side of the bin, then it's going to stall out there, and it's going to stall there, and more grain is going to build up until you plug your system. Don't do that. Setting this high enough that it is able to carry grain but not damage grain is the key here. By having the minimum frequency at 40 in 90% of the sites, that's going to be more than adequate to prevent grain damage and make the pipes last longer and the elbows last longer and not plug your air system. Last, we have the dynamic bleed valve control settings. Once again, here's a great example. Our dynamic bleed valve currently is a Belimo actuator, and it is a 2 to 10 volt DC signal. So as you can see by default, we have 2 volts, 10 volts DC. So that allows us to use that. If we switch to a different actuator, for example, a Siemens SQM50, for example, or an SQM100, we would be able to put in the voltage signals that those are rated for and use that if we needed to. On the left-hand side here, we have percentages. And these are the minimum and maximum, not how far it can open limits. These are how far it can open in automatic control. And so I want to point that out. In the same way for the VFD, we use the minimum frequency at 40 to prevent plugs. On a dynamic bleed valve, we're going to use the maximum frequency to prevent plugs. And so I would set the maximum, the maximum percentage. The maximum percentage of 40 to prevent plugs. And what that does for us is it says you can't open the bleed valve when you're in automatic control any more than 40% open. If you go past that, you bleed enough air off that once again the grain doesn't travel up the pipe, it gets plugged on the side of the pipe, and then you're plugged and down and out. By having that maximum control position open to 40, it prevents it from opening enough that it bleeds enough air off, so it's able to continue to blow air down the pipe and keep the grain moving but not damage grain and not plug your air system. If you are running in dynamic bleed control and your air system starts to plug, the first thing you should do is come into your dynamic bleed valve control settings, go to the max auto control position and lower that number down. So it's opposite of the VFD. In the VFD, you'd want to raise the minimum. On the DBV, you want to lower the maximum. So for example, if you were plugging at 40, you would want to lower that number to 35. The DBV cycle time in seconds at the very bottom here, that's 35. And what that is that's for how long it takes the actuator to move from fully open to fully closed. That's used in the mathematical calculation, and the reason that's entered in here is if you did go to a Siemens like SQM, for example, that might have a fully open to a fully closed of X seconds, whereas the one we're using right now is 35 seconds. So for part of the auto unplug, we need to know how long it takes the valve to move for the cycling so that we don't apply too much pressure for too long or too little pressure for too long. And so that's what that number is. If you were to change the actuator out to something else, you need to change the cycle time for the valve. That concludes the settings for the air system, basic settings and advanced settings. The last setting that we have is the auto control. As you can see here on the auto control page, there's control mode type. And there's a selection here where you can choose from 4 different types. DBV, pressure control mode PID. There's VFD, pressure control mode PID, VFD, pressure control mode custom, and DBV, pressure control mode custom. Those 4 different possibilities are important based on your dryer type. For example, if you have a Super B dryer that turns up or turns down quickly, you do not want to use the custom mode. It will plug and you will be unhappy, and that is not Sukup's fault. If you buy a Sukup dryer, it turns up and down slowly and is much more consistent, and you'll be much happier with the custom mode. 90% of the dryers out there should be run in the custom mode. However, if the dryer turns up or turns down very quickly, as an example I gave you, you're going to want to run in PID mode because it increases and slows down very fast. However, it will not run smooth. It will constantly hunt up and down. And so if you have a VFD, you should run in VFD pressure control mode custom. If you have a dynamic bleed valve, you should run in dynamic bleed valve custom control mode.